Hello everyone. So today we're going to be covering section 6.4 and section 6.5 of the textbook. So starting with section 6.4, we have a definition of like radicals. So two radical terms are called like radicals if they have the same index and the same radicand. And so recall, what is an index and what is a radicand? So if I had the nth root of a, n is the index, a is the radicand, right? So now erase this, and then let's start on section 1 of the first topic of our daily packet, which is square root addition or subtraction, not of. So our directions are to simplify. In our example, we have the square root of 32 plus 2 square root of 72. So we want to simplify this. So right off the bat, so when it comes to radicals, it's kind of like x. So if I had 2x plus 3x, we can add these together, right? Because if they have the x in common, so if I factor out the x, I get 2 plus 3, and then this becomes 5x. However, if I had like 2x plus 3xy, this cannot be added together, right? So same thing goes for radicals, right? But there's two conditions this time, where it has to have the same index and it has to have the same number under the square root. So now let's start with the example. So before we can add these, we have to make sure they have the same number. So they both have the same index, which is good. And now our goal is to get the same number under the radical. How do we do that? We're going to we're first going to simplify each square root. So for the square root of 32, I'm going to look at my chart over here, and I'm going to find the first our goal is to find the very first perfect square that goes into 32 nicely. So the first number that is smaller than 32 is 25, but 32 does not go into 25 evenly. And then I look at 16, but 16 times 2 is 32, or 32 divided by 16 is 2. So how can I rewrite 32? I can rewrite it as 16 times 2. Right? So now let's look at the square root of 72. So the first number that I see smaller than 72 is 64, but 72 divided by 64 does not divide evenly. And then 72 divided by 49, that also doesn't go in there nicely. And then there's 36. So 36 times 2 is 72. So how can I rewrite 72? 36 times 2. Right? And now let's use the multiplication property. So square root of 16 times 2, this becomes square root of 16 times square root of 2. And this becomes square root of 36 times square root of 2. Right? And then now let's solve. So the square root of 16, that is 4, because 4 squared is 16. Square root of 2, it's as reduced as it can get. And here's this. So, and then 36, that is, or the square root of 36, that is 6, because 6 squared is 36. And square root of 2 is as simplified as it is. So now we have 2 times 6. So I have to do that first. So 4, let's bring down the 4 square root of 2. And then 2 times 6, that is 12. So now we want to add 4 square root of 2 and 12 square root of 2. So just like the x's, the reason why we can add these together is because since they have a square root of 2 in common, we can factor that out, and we'll get 4 plus 12. And then so this becomes 16 square root of 2. Right? So now what I'm going to show you guys is what is the least I expect from you. So if you'd like, so instead of rewriting it, I'll just erase what we don't need. So I still need you to show me this, right? But the step 2, if you're comfortable, so since if you know that the square root of 16 is 4, and then like these if you understand the step, then you can just skip it. You can just go ahead and tell me this is the 4 square root of 2 plus 2 and then times 16 square root of 2. And then so I'll need this and then multiply the 6 and 2, and then you don't need this. You can just go ahead and tell me that this is 16 square root of 2.